This is section 2-8, Proving Angle Relationships. And this is a very long section, so I'm going to actually break it down into two videos. The first one is going to be all of the postulates and theorems that we'll be using that are very important, and then I'll do part 2 where I just do several proofs that show you how to use these. So the first one is the angle addition postulate. It says that point D is a point in the interior of angle ABC if and only if angle ABD, the measure of angle ABD plus the measure of angle DBC is equal to the measure of angle ABC. Kind of like the segment addition postulate where the two little segments added up to the big one. In this case, the two smaller angles add up to the larger angle. And that's angle addition postulate. This is the supplement theorem. If two angles form a linear pair, then they are supplementary angles. So angles 1 and 2 form a linear pair because they're basically a straight line with a ray coming out of it. If they form a linear pair, then the measure of angle 1 plus the measure of angle 2 is 180 degrees. That's the definition of supplementary, that the two angles add up to 180. But since they form a linear pair, the supplement theorem says they are supplementary angles. We also have the complement theorem. If the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. Let's take a look at that. The non-common sides of two adjacent angles. Angle 1 and angle 2 are adjacent because they share this ray that comes out in the middle. And they're non-common sides. That is the sides that they don't share. So that would be this ray going straight up and the ray going out to the right. Since those form a right angle, and then you have a ray coming out of the middle of it, then those two angles are complementary. So if angle 1 and angle 2 form a right angle, then the measure of angle 1 plus the measure of angle 2 equals 90, which is the definition of complementary angles. If two angles form a right angle, then they are complementary. Here are some properties of angle congruence. Reflexive, angle A is congruent to angle A. Symmetric, if angle A is congruent to angle B, then angle B is congruent to angle A. And the transitive property, if angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. The congruent supplements theory. Angles supplementary to the same angle or congruent angles are congruent. Okay? What this is saying is if angle 1 and angle 2 are supplementary, and if angle 1 and angle 3 are supplementary, then angle 2 is congruent to angle 3. If 1 and 2 add up to 180, and 1 and 3 add up to 180, then 2 and 3 must be the same. Here's the congruent complements theorem. Angles complementary to the same angle or congruent angles are congruent. If angle 1 and angle 2 are complementary, and angle 1 and angle 3 are complementary, then angle 2 and angle 3 are congruent to each other. If angle 1 plus angle 2 equals 90, and if angle 1 plus angle 3 equals 90, then 2 and 3 must be the same. Vertical angles theorem. If two angles are vertical angles, then they are congruent. Remember, vertical angles are formed when lines cross, and those are the angles that are opposite each other. So angles 1 and 2 are vertical angles, so angle 1 is congruent to angle 2. Angle 3 and angle 4 are vertical angles, so angle 3 is congruent to angle 4. And here's a whole bunch of right angle theorems. Perpendicular lines intersect to form 4 right angles. So if line AC is perpendicular to line BD, and remember this little upside down T is our symbol for perpendicular. So if those two lines are perpendicular, then angles 1, 2, 3, and 4 are all right angles. Second theorem, all right angles are congruent. If angles 1, 2, 3, and 4 are right angles, then angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. So all right angles are congruent to each other. Perpendicular lines form congruent adjacent angles. So back in this picture, if AC is congruent to BD, if AC is perpendicular to BD, then angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, angle 3 is congruent to angle 4, and angle 4 is congruent to angle 1. Next theorem, if two angles are congruent and supplementary, then each angle is a right angle. So if angle 1 is congruent to angle 2, and if angle 1 plus angle 2 equals 180, then they're supplementary, then each one has to be a right angle. Kind of makes sense if two angles are congruent to each other, and they add up to 180, each one is going to be half of 180, or 90, which makes it a right angle. And if two congruent angles form a linear pair, then they are right angles. So if angle 1 and angle 2 form a linear pair, and if angle 1 is congruent to angle 2, then angle 1 and angle 2 are right angles. And those are all of the properties and theorems and postulates that we're going to use in our next section. Part 2, I will do some of the proofs for you.